Hello everyone. This video covers lecture notes 1, which means these are the lecture notes for week number 1. It covers sections 1.3, 2.1, 2.2, and 2.3, which are pretty much, this is a review of intermediate algebra. Actually, the majority of the class is stuff you have seen in intermediate algebra. We're just gonna go deeper into the topics. Of course, there is also new things, but the majority is stuff that you should have seen at some point in your life. So in section 1.3, we're gonna talk about functions and using find the linear functions using the Points-Law formula, which the formula is y minus y1 equals to m times x minus x1. And then the special case of this one, which is y equals to mx plus b. You can also find linear functions using the x and y intercepts. And the idea is to interpret what the slope means and do linear models in context, which is this part right here, this problem. Also, we're going to create piecewise functions, which is section 2.1, 2.2. We're going to use the vertical line test to determine if something is a function or not. And then finally, we're going to talk about the domain of a function. So that's what we will cover in this video. All right, so let's do an example of a linear function and see how this works. The problem says the following. A small business buys a computer for $4,000, and after 4 years, the value of the computer is expected to be 200. Now, for accounting purposes, the business uses linear, so this is key to what we're going to do. So linear depreciation means you can just use the slope formula to find the line. So here we define b to be the value of the computer at time t, and t obviously is the time in years. Okay? So t will be the time in years, and bt will be the value for the computer. Okay, so this will be in dollars, and this will be in years. All right, so part A is asking you to find a linear model, which is just a fancy name to say find the equation of the line. So this is asking you to find the equation of the line, which means you need to use y minus y1 equals to m times x minus x1. All right, so we need to find 2 points. The first one is 0, 4,000, because the value of the computer is 4,000 right now. Then in 4 years, the value of the computer goes down to $200. So therefore from here, so we're doing part A, you have the following order pair, 0, 4,000. And the second one is 4 and 200. This one is x1, y1, x2, y2. So the first thing we need to figure out is the slope. So remember, the formula for the slope is y2 minus y1 over x2 minus x1, which in our case this will be 200 minus 4,000 divided by 4 minus 0, which is minus 950. So then if we use this equation using this point, we get the following: b minus 4,000 is equals to minus 950 times t minus 0. So therefore this is y1, this is x1. So from here we have the b is equals to minus 950t plus 4,000. So this is the answer to part A. Now b, you can also rewrite it as b of t. It doesn't matter, it's the same thing, because it's assumed that b is a function of t. And in this case, b is the dependent variable, so this is y and t is x. Notice that this is also y equals to mx plus b, the exact same formula. Alright, so this is part A. This is the answer to part A. Part B is asking for the slope and the y-intercept. So the slope, remember, was equals to minus 950, which is what we have from here. This is the slope. And the y-intercept is the point 0.04,000. So it's asking you to interpret this in context. So what does that mean? Well, this point means the initial price is was $4,000, and the minus 950 means the computer depreciates at $950 per year. So every year the computer goes down in price by $950. All right, part C is asking you to do the graph. So to do the graph, you can use this points right here. So when x equals to 0, this is equals to 4,000, and if x equals to 4, this is 200, which is somewhere here. Here you need to label the axis. So this is the number of years, and this is the price in dollars. And then you do a straight line. Just do it like this. Now there is nothing on this side because time is not negative, and the price of the computer cannot be also negative. So up to this point, it will be the domain. So the domain is gonna go from, in this particular case, from 0 to 4 point something. It cannot go to 5 because at 5 it will be negative. This is part C. And then finally part D, it says for how long the computer will be worth more than $2,000. Approximate using the graph. And you can use algebra to get the exact answer. Now you can see that the computer starts at $4,000. It goes down. At this point is 2,000, so it takes around two years to get to 2,000. So for less than 2 years, the computer, or for around 2 years, the computer is worth more than $2,000. So now if we want to know the exact value, then we can use algebra, and we're going to use this function. So we want to know how long it will take to get to 2,000. So then bt becomes 2,000. So it will be minus 950t plus 4,000, and then just solve for t. So in this case, you're gonna have minus 2,000 is equals to minus 950t, or t is equals to 2,000 divided by 950, which is around 2.11. So it takes exactly 2.11 years to get to 2,000. So that means that before that, the computer was worth more than $2,000. And also remember that the domain T is between 0 and 4.1 or 4.2. It cannot be negative, so around 4.1, 4.2. All right, so now let's go to next page, which is now talking about piecewise linear functions. All right, so first of all, what is a piecewise linear function? In case you forgot or you have never seen it before, piecewise just means that you have more than one linear function. So for example, f of x could be this, like 2x minus 5 if x is bigger than some specific number, and x plus 7 if x is less than some specific number. So you have more than one function. And this problem will explain exactly what this is. All right, before we do this problem, there's a typo here, a long typo. I fixed it on the official notes, I think, but if not, here's the typo. So the first part is correct. A cell phone plan costs $39 a month. The plan includes 2 gigabytes of free. This should be free data. Okay. And then it charges a rate of $15 per gigabyte for any additional data, because nobody uses the cell phone to talk anymore. We only use it for data. So the question will be, construct a model for the monthly cost of the plan if the buyer uses X gigabytes of data. Okay, so this is the problem that we're actually trying to solve. All right, so before we start the problem, C of X is currently the cost of the plan, and X is going to be the number of gigabytes. So therefore, the first linear equation is going to be the following. C of X is going to be equals to 39 if the amount of gigabytes you use is between 0 and 2. Even if you don't use anything, you still have to pay the $39. So we need to have 2 points to find the slope of the other line. So how do we incorporate the 15 into this? Well, from here, if you use 2 gigabytes, you still pay $99. Okay? But let's say that you use 3. If you use 3 gigabytes, you still have to pay the 39 plus 15 more, which will give you 54. So this is the 39 you have to pay plus 115, which will give you 54. Right, so we find the slope again exactly this in the same way we did in the previous example. This will be x1, y1, x2, and y2. So the slope will be now 54 minus 39 divided by 3 minus 2, which is 15. Which it shouldn't be surprising because you have to pay $15 for each extra gigabyte. All right, so now we need to find the equation of the line in the exact same way we did it in the previous method. So remember, we have y minus y1 is equals to m times x minus x1. So in our case, y is z, so this will be y minus 39 is equals to 15 times x minus 2, or y is equals to 15 x minus 2 plus 39. And this is enough, but you can simplify it more. So this is 15x, then minus 30 plus 39 is 9. So therefore the value for the function, so the answer to part A will be this. C of x is equals to 39 if 0 is less than equals to x less than equals to 2, and equals to 15x plus 9 if x is greater than 2. Now, what is the domain of this function? Well, we have to be realistic. You can just say that x is greater or equals to 0. Obviously, x is not going to be a million, because then you're going to pay a lot of money. And when we do the graph, it will be easier to see why the domain is just x is greater or equals to 0. And it's also asking you to divide it into two parts. Well, these are the two parts. Now remember that this and this is exactly the same thing. So it's up to you. You want to write this or this. Now part B is asking you to find C of 0.5, which means you're only using half of a gigabyte. But remember, the plan is $39. You use between 0 and 2. Doesn't matter how many you use between those two. So therefore, this is equals to 39. So you only use half of a gigabyte, you still have to pay $39. Now, what about C of 2? Well, this is also 39 because it was up to 2. But what about you use 4.5 gigabytes? Well, if you use 4.5, then the price is going to be now 15 times 4.5 plus 9, which is equals 76.5. So the cost of using 4.5 gigabytes, it will be $76.50. Part C is asking you to do the graph. So part C. Now before we do the graph, the axis label, remember that this is supposed to be gigabytes, and this is the price. Now this originally was minutes, so I'm just gonna change this to gigabytes so that it makes more sense. Okay. All right, so if you use between 0 and 2 gigabytes, you had to pay $39, which is somewhere here. So it doesn't matter if you use 0 or you use 2, you had to pay $39. Then after that, the slope is 15. So you can see that this is the slope of the line. And the y-intercept from this point is 9. You can also use the original points we used to find the slope. Remember, if you use 3 gigabytes, you had to pay $54. So at the point 3, this is supposed to be 54, which is somewhere here. And then at 4.5, this will be 76.5, which is somewhere here. So the second line will look like this. Now from here you can see the domain is x is just greater than 0, but you have to be realistic. You cannot use like a billion gigabytes for many reasons. So therefore the domain has to be constructed to something more realistic, but for now you can just say the domain is x is greater or equals to 0, and that's it. Now in this exercise they already give you the graph, so you had to figure out the equation. Now notice that the x values go from 1 all the way to 6, not including 6. So therefore the domain is going to be 1 less than equals to x less than 6, because it doesn't include the number 6, or in interval notation it will be 1 comma 6 parentheses. So that's the domain. Alright, so now since you have 3 equations, so let's say this is equation 1, equation 2, and equation 3. And for lack of a better name, let's just call this one f of x and this x. So we're trying to find the pieces for the function. Now the easiest one is this one. Clearly this is just equals to 4 between 3 and 4. So therefore that's what we say. So you can say that this is equals to 4 when x is between 3, not including 3, and equals to 4. Alright, so now let's look to equation number 1. And we're going to use the exact same formula and method that we use in the last 2 examples to figure out the equation of the line. So notice that this is the point 1, 3, and this is the point 3, 1. So therefore, if we use the slope formula, this will be 1 minus 3 over 3 minus 1, which is minus 2 over 2, which is negative 1. Then if we use the equation of the line, y minus y1 is equals to m times x minus x1. Now you should check that this simplifies to y is equals to minus x plus 4. So therefore the second equation, which will correspond to equation 1, is this one. And here we only write this part. So we say that we got minus x plus 4 if x is between 1 and 3, including 1 and 3. So the only thing we need to figure out now is this one. And we're going to use the exact same method again. Notice that this is the point 4, 2. This is the point 6, 4. So first thing, find the slope. So the slope of this line is 4 minus 2 over 6 minus 4, which again is equals to 1. Well, not negative 1, but it's positive 1. So therefore for equation 3, the equation of the line will be y minus y1, which will be, in this case, y1 is equals to 2. Then the slope is 1 times x minus 4. And you can check that this simplifies to the following. Y is equals to x minus 4. Well, you add 2 to both sides, and it will give you y is equals to x minus 2. So this will be the third equation. So therefore, the last piece will be this. This will be x minus 2 when x is between 4 and 6, not including the 4 and not including the 6. That's why we don't have the equal sign here. And that's it for this part. Now the next example, this is a very special formula that you will use in calculus. You take calculus. Here, the domain you can see is from 2 to 6, but there is a hole in here. So that means that the domain, there is many ways to write it. The laziest way is the following. You can say all x values between 0 and 6 except for x equals to 4. But that takes way too long to write, but it's perfectly fine if you do them. The easiest way is to say is the x is between 0 and 4 and then 4 and 6. This means 4 is now part of the domain. Or you can simply say x is not equals to 4. And this will be the domain. Okay, so you can see at this point it's not defined. But you still can find the equation because this is still a line. All you need are two points. So this point, you can also use, I guess, this point. So the first one is clearly 0, 3. The second one is 3, 3, 9. So if we use the slope formula again, this will be now 9 minus 3 over 3 minus 0. So therefore this will be 6 over 3, which is 2. And then the equation is going to be y equals to 2x plus 3, because the y-intercept is 0. Okay, so this is the equation, except this is not true when x is equals to negative 4. So you cannot plug in the value for x equals to 4 because at that point it's not defined. And this is not going to be a big deal now, but if you ever take calculus, this is a big deal there. Now this is completely related to the next part, which is asking the following. Is this true or false? Is this equals to this no matter what value of x? Okay, so no matter what value of x is. And this is actually false, because even though, yeah, you can cancel this, if x equals to 0, if x equals to 4, this will give you 0, and one of the only few things you can do in math is divide by 0. So note, in math, you can not divide by 0. That's the biggest thing you can do in math. And this is completely related to the domain. So even though you can in theory cancel this 2 and you will have this left, well, this is not always true, because it says no matter what number of x. So if that's the case, this is false. And all you have to say is because it is not true when x is equals to 4. Now, if you compare the graph of this one and this one, the graph are almost identical. So this could be the graph of 2x plus 3, and then the graph of this one would look like this too, except that it will have a hole in there, which is technically this is this graph right here. So this is actually this graph. But if I only ask you to graph this by itself, then the graph looks like this. There is no holes anywhere. Right, so in this part we're going to find the domain of functions. And like I already told you in the previous page, there's technically two things you can do in math, and this is related to the domain. The first one I just told you, but let me repeat it. So you cannot divide by 0. The other thing you cannot do in math, at least for now, is like you can not take a square roots of negative numbers. So these are the only two things where you will run in trouble for to find the domain. Otherwise, the domain is pretty much always everything. For example, here, clearly you are dividing, and since you are dividing, you are risking dividing by 0. So therefore, what you do is you say, well, when is this equals to 0? You can factor the x, and you can see that this is equals to 0 when either x is 0 or x equals to 3. So therefore, these two cannot be part of the domain. Okay? So these two numbers are prohibited. They cannot be part of the domain. So like I just mentioned, there are several ways to write this. So the laziest way will be to say this: the domain, you say x cannot be 0 and x cannot be 3. So that would be the lazy way. Now the fancy way, it will be to use interval notation, and you could say is all the values from minus infinity to 0, not including 0, or 0 to 3, not including 0 or 3, or 3 to infinity, not including 3. And this is what is called a interval notation. So here where it says domain interval notation, well, this will be minus infinity to 0, or 0 to 3, or 3 to infinity. In the graph, so here you have 0, 1, 2, 3, 4, minus 1. So you can have 3, and you can have 0. So the domain, like we say right now in here, is everything except for those two values. Now you can either use the open circle, you can also use parentheses if you want. Either way it's fine. But it makes more sense to use the parentheses, because notice since this has a parenthesis, it has a parenthesis. If this was a bracket, this would be a bracket. Alright, in the next one we have a square root. And I told you we can have a square root of negative numbers. So what you have to make sure is that the inside of the integral is positive, which means this x minus 3 has to be greater or equal to 0. It can equal 0, that's not a problem. So therefore that means that x has to be greater or equals to 3. Okay. So therefore the domain in interval notation is gonna go from 3 to infinity, because if you do the graph, you have 0, then 1, 2, 3. So this includes the number 3, so this is the domain, any number greater than 0. By the way, if you have this or this, we're going to use parentheses. If you have this or this, we're going to use brackets, or this will be an open circle and this will be a closed circle. So it's up to you. So just note this. Alright, so let's try the next one. Again, this is a radical or a square root. All you have to make sure is this part is positive, so we need this to be greater or equals to 0, which means that minus 2x is greater or equals to negative 5. Remember that if you divide by a negative number, you have to flip the inequality. So that means that x is less than or equals to 5 over 2, which is 2.5. So now let's do the graph first this time. So you have 0, 1, 2, 3. That means 2.5 is somewhere here. So this is 5 over 2. So this is less than or equal. This is going to the left side, and we're going to use a bracket. So this is the answer. Now, if you want to do this with a closed circle, that's perfectly fine too. But the bracket is more appropriate because of this. If we use the interval notation, you can see that it goes from minus infinity to 5 over 2. So this will be minus infinity 5 over 2. Or you can write minus infinity to 2.5 with bracket. Either way is fine. So now just a final note on interval notation. For interval notation, you're always going to use a parenthesis or a bracket or a bracket or a parenthesis. But in either case, the first value always has to be the small one, and the second one has to be the biggest one. So that's always the case. So the small value goes first, and then the big one goes second. And notice here, this one is going all the way to minus infinity, so there is nothing smaller than minus infinity, so that's why that one goes first. Well, while here, this one is going from 3 to infinity, so clearly the biggest value is infinity, so that's why it was second. So the small one goes first always, and the biggest one goes second. Right now, this one looks almost identical to the previous one, and it is identical on the bottom, but now you are dividing by this, and remember you cannot divide by 0, so that changes things slightly. Before we have this 5 minus 2x is greater or equals to 0, so you cannot have the equal anymore, so this has to be greater than 0. And from what we did right now, that means that x now has to be less than 5 over 2, which was 2.5. So therefore the graph is going to change to this now. You're going to have 0, you have 2.5, but now you're going to use a parenthesis instead of a bracket, and the interval notation is going to go from minus infinity to 2.5 using also a parenthesis. Now part E, this is as hard as it gets, because you have to worry about the radical, and you also have to worry about not dividing by 0. So here, the first thing we do is make sure that this is positive. So that means that x has to be greater or equals to -2. So that's the first part. And the second part, it says that x minus 5 is equals to 0. So that implies that x is equals to -5. So therefore, x equals to 5, so positive 5 cannot be part of the domain. So before we write an interval notation, the best thing is to do a graph. Always use 0 for reference. -2 is somewhere here. 5 is here. Now remember that 5 cannot be part of the solution because if x equals to 5, you are dividing by 0. Okay? But for this part, x can be any number greater than -2, including -2. So therefore, for this part, it's okay until you get to 5. We're using a bracket. And once you go over 5, this is okay again. So this is the graph. So therefore, in interval notation, this is going to be from -2 to 5 using a parenthesis. Again, notice this is the smallest value, this is the biggest value. Or from 5 to infinity, this is also the biggest value, which is infinity. By the way, infinity or minus infinity, so note in here, infinity or minus infinity, always use parentheses. Never use a bracket. So you do this, let's say minus 5 to infinity. This is a sin. You will not go to heaven if you do that. So never do that. Okay. Now part F, which is the last part, is actually the easiest one. And this is a polynomial. Notice that you are not taking a square root and you are clearly not dividing by anything. So nothing can go wrong here. So for something like this, the domain is all real numbers. Or you can write an interval notation from minus infinity to infinity. Now finally, here you have a specific equation that is telling you specific information about the problem. So here the problem says a tank holds 50 gallons of water, which drains from a leak at the bottom, causing the tank to empty in 20 minutes. The tank drains faster when it's nearly full because of the pressure of the leak is greater. And then there is some physics law, which you don't have to worry about it. But so this is given, this is the formula. And notice that here, the domain is actually given to you. So this is the domain. So it's given. Now the question is, why does the author choose to state the domain explicitly in this example? Since this is a physics problem, the reason why they give you the domain specifically, it means that outside this interval or outside this domain, this formula doesn't hold true, or whatever it gives you doesn't make any sense physically or from a physics point of view. So that's why they tell you the domain and say this formula or this model that we're using is only true between these values of x or t or the domain. So that's why they choose to give you the domain explicitly